students, factors on which the resistance depends. So for this we have to perform an activity, which is activity 12.3 in your NCERT books. In that activity, first you have to take a wire of length L1, then you have to note down the reading of the ammeter. That will give you the amount of current flowing through this particular resistor. Right? Now what are you going to do is you are going to increase the length. But the wire is same, material is same, area of cross section is same, only the length has increased. Now after the readings of the ammeter, you come to know that the amount of current in this wire was more than the wire which is longer. Okay, so after this observation, what do you come to know is that yes, the resistance is directly proportional to the length of the resistor. Okay, that is more the length, more the resistance, less the length, less the resistance, and hence if the resistance is less, current is more, and if the resistance is more, the current is less. Okay, is this clear? But provided the area of cross section, material and temperature remains the same. So let us say that R is proportional to L, equation 1. Okay. Now students, what I did is I took the wire L1 with area of cross section also A1. Voltage battery is not changed, right? And I take the reading of the current. Fine. Now let us say this. Length is L1, area is A1, voltage is V. Okay. And let us say the current is I1 for this voltage. Okay. Now I double the wire. Now I have increased the area of cross section, right, by folding the wire on its length. So the length is now same, but the cross sectional area has increased. I keep the voltage same, material same, temperature same, and I note down I2. Now what do I observe is I2 is greater than I1. So from this observation we conclude that the resistance of a conductor is inversely proportional to the area of cross section. Is this clear? Right? Now there is another activity, I think 12.2 in your books, where what you do, 12.2 NCERT book, where what you do is you change the material of the wire. Let us say it was nichrome wire. So IN, current through nichrome wire. Then you take copper wire. And let us say IC is the amount of current flowing in copper wire, provided the length L, N and LC and area of nichrome and area of copper are same, temperature is also same. What is your observation? That the current flowing through copper wire, that is the current through copper wire, is greater than current through nichrome wire. It means the resistance also depends upon the material. Okay. So number 1, resistance of a resistor depends upon length. Number 2, area of cross section. Number 3, material. Number 4, temperature. Now for temperature, what we have to do is we have to keep the key plugged. You take one reading, wait for some time, keep plugged, and take the other reading. Now the length and the area and the material is absolutely same, but you find that now the value for the current has decreased. It means that the resistance of a conductor increases with the rise or increase in temperature. So again I repeat, you have to unplug the key in between the readings. Okay, I think it's clear to you now. So there are four factors on which the resistance of a conductor depends. Number one, length, directly proportional. Number two, area of cross section, inversely proportional. Number three, temperature, directly proportional. And then it depends from material to material. So when the resistance of a material is very high, like that of wood, that of glass, such materials are called insulators. Then the materials which offer less resistance, they are called conductors, like copper, silver, right? And then the nichrome, etc., tungsten, right? Constant turn, these are the materials with the resistance which is less than that of insulators but more than that of conductors. So on the basis of the resistance we divide materials, and on the basis of their material we decide which type of resistor we have to use in a particular appliance. Like for electricity you will not use nichrome, you will use copper. But for a geyser, for a electric iron, you will be using a nichrome wire. I hope I am clear. Now from equation 1 and 2 we get R is proportional to L by A. Okay, if we remove the sign of proportionality, we come to R is equal to rho L by A. Now what is rho? Rho is the constant of proportionality and it is called the specific resistance or the resistivity of a given material. Okay, so now first we will define resistance. So resistance of a conductor is the numerical ratio between the applied potential difference and the current flowing through it, or it is the resistance offered to the flow of electrons. Is this clear? Okay. Now what is the unit? So unit of resistance will be, let us say, volts upon ampere equal to ohm, in honor of the scientist who gave us this law, and it is denoted like this symbol. Okay, now how to define 1 ohm? So the resistance will be 1 ohm if the potential difference is 1 volt and the current through the circuit is 1 ampere. We say that the resistance is 1 ohm. I think this is clear. Now I move to the topic of resistivity. So rho RHO, it is pronounced as rho. Rho is equal to R into A upon N. Okay, this is the mathematical formula for finding the specific resistance or the resistivity. Okay, now dear children, please pay attention. If the area of cross section is 1 square centimeter, length is 1 centimeter, or 1 square meter, 1 meter, then can I say that resistivity of that is equal, numerically equal to the resistance? Can I say? Right? So we can define resistivity or specific resistance as the resistance of a conductor, a resistor, which is of unit area of cross section and of unit length. Okay. In the other words, we can also define resistivity as the resistance offered by a cube of a material with side unit, right, when the current is flowing perpendicular to its parallel surface. Okay. Now, the factors on which the resistivity will depend. Very, very important. Resistivity is independent of the area and length. Okay. Rho, resistivity, does not depend upon length and area of cross section, but it depends upon the temperature and material. Okay. So first thing, resistivity is independent of the length or the area of cross section of a given wire, right? If I say that this is a wire of resistivity R, or we can say rho. Okay, let us not say R. So this is a wire with resistivity rho. Okay. Now I say that I have increased the length of this wire, doubled. Now what will happen to its resistivity? It will again remain same rho. Okay. Then I say that this is a wire with resistivity rho and I fold it. Now its length has become half, area has become double. Then what is its resistivity? No change. It will again remain same because resistivity does not depend upon the length or the area of cross section. Okay. Now if I say that this wire is of copper, okay, and this wire is of nichrome, so the resistivity is not same because the material is different. Okay. Now I come to another example that this is a wire at a temperature of 40 degrees Celsius, okay, and it has resistivity rho. Now the same wire, same material, same length, but the temperature has now been raised to 80 degrees Celsius. Now the resistivity will not remain same. Okay, fine. Now that is all for resistivity. We should also talk about the units. So resistivity is equal to what? R into A upon L. So ohm square meter upon meter. So meter, this will cut. So units of resistivity rho are ohm meter. So thank you so much. I hope you will understand this topic.